Welcome, team. Today, we are focusing on a critical phase in machine learning operations, comparing model performance across different training jobs. We will learn how to systematically evaluate runs, cut through the noise, and confidently select the best model for production. Let's kick things off by defining what we mean by model comparison. In a real-world scenario, you rarely train just one model. You experiment. You run dozens, maybe hundreds, of training jobs, tweaking algorithms and hyperparameters. But how do you know which one actually won? That is where systematic model comparison comes in. We do this because guesswork in data science is unacceptable. We need hard, objective evidence to prove a model's effectiveness before it ever touches production. How do we achieve this? We centralize our job telemetry. By doing so, we shift our engineering mindset from single-run training to orchestrating massive parallel experiments, letting our tools mathematically surface the absolute best model. Take a look at this flowchart. On the top, we have our multiple training jobs. These are all your different experiments running in the cloud. They all feed directly into a centralized evaluation engine. This engine allows us to systematically compare logged metrics, like accuracy or loss, side by side. Finally, this data-driven comparison leads us directly to selecting the optimal model for deployment. Before we can even think about comparing jobs, we need a standardized way to record their performance. This is where MLflow becomes our best friend. Think of MLflow as the foundational tracking layer. If one data scientist writes logs to a text file and another prints them to a console, comparing their jobs is impossible. Why? Because we lack standardization. How do we fix this? We mandate MLflow tracking in all our scripts. When jobs run, MLflow automatically captures parameters, metrics, and output artifacts in a uniform structure. This means whether you are training a massive neural network on a GPU cluster or a simple logistic regression on your laptop, the results are stored identically, making true apples-to-apples comparison a reality. Here we see MLflow acting as the great equalizer. We have two wildly different training jobs on the left, a neural net and a random forest. Because both jobs are configured to use MLflow logs, their distinct performance telemetry is routed into the exact same central MLflow registry. This unified data store is what makes our standardized downstream comparison possible. Now, let's talk about scaling our comparisons using sweep jobs. A sweep job is Azure Machine Learning's automated engine for hyperparameter tuning. Instead of manually starting a new job every time you want to test a different learning rate, you define a search space, and the sweep job spins up multiple trial jobs in parallel. Why is this powerful for comparison? Because the sweep job natively compares the trials against each other. How does it do this? It relies on the target metric you log via MLflow. Here is a deep dive tip. By configuring an early termination policy, the sweep job actively monitors the metrics. If it sees a job performing terribly compared to the best current trial, it kills the loser automatically, saving you massive amounts of compute budget. Notice how the sweep job orchestrator at the top spins out multiple parallel trials. Trials 1, 2, and 3 test different learning rates simultaneously. As they report their metrics, the system compares them in real time. Look at trial 2. The dotted line indicates an early termination. The system realized it was underperforming compared to the others and shut it down. The surviving trials are compared to select the ultimate winner. In an enterprise environment, your data science team will likely use a mix of techniques. They will run automated ML, or AutoML, jobs to establish strong baselines, and they will run custom Python script jobs to test highly specialized architectures. We absolutely must compare these two different worlds. Why? To prove that the hours spent hand-coding a custom model actually yielded better results than the automated baseline. How do we do this? It goes back to our foundation, MLflow. Because both AutoML jobs and custom notebook jobs write their telemetry to the MLflow backend, they live in the exact same workspace. This breaks down silos. An engineer can seamlessly overlay the performance of an automated run against a custom run and definitively declare the superior approach. This flow shows the convergence of methodologies. On the left, we have our high-speed AutoML experiment runs. On the right, our highly tailored custom Python script runs. Despite being generated differently, both feed directly into the shared experiment workspace. This convergence is what allows us to perform a cross-job unified comparison, ensuring the absolute best model wins, regardless of its origin. We have captured all this wonderful data. Now we must analyze it. We use the Azure Machine Learning Studio UI to visually evaluate and compare our job metrics. The Studio acts as our analytical dashboard. Why is this UI so important? Because humans are not designed to read thousands of rows of raw JSON telemetry. We are visual creatures. How does it work? You simply navigate to your experiment, select the different jobs you want to compare, and generate visual charts. This is where the deep insights happen. By overlaying the loss curves of 5 different jobs, you can instantly spot which model converged smoothly, which one was unstable, and which one started to overfit. Visual comparison is the fastest route to a confident decision. Follow the user journey here. The engineer starts by selecting multiple jobs in the studio. The studio generates a visual dashboard, allowing the engineer to overlay performance curves. By analyzing the shape of these curves, the engineer can easily identify issues like overfitting or training instability. This visual clarity directly enables a highly confident, data-driven model selection. When you are staring at a dashboard comparing 50 different jobs, how do you sort them? You must select the right evaluation metric. It is critical that your mathematical criteria align with the actual business problem. Why? Consider a fraud detection scenario where only 1% of transactions are fraudulent. If you compare jobs based solely on accuracy, a terrible model that just guesses not fraud every time will look 99% accurate. That is highly misleading. Instead, you must use the studio's tools to sort and compare jobs based on robust metrics like AUC weighted or the F1 score. For an expert-level deep dive, you can also bring the responsible AI dashboard into your comparison. This allows you to evaluate models not just on raw predictive power, but on fairness and transparency across different demographic cohorts. This diagram highlights the metric selection process. It starts with analyzing the business problem. This drives the crucial decision: select primary metric. If the data is balanced, we might sort jobs by accuracy. But for tricky, imbalanced data, we route to sorting by AUC weighted. Both paths then pass through the responsible AI dashboard to check for fairness, leading us to our final job ranking. Let's bring this to life with a real-time use case based on our Azure Machine Learning training scenarios. Imagine an organization building a critical classification model to diagnose a medical condition from patient records. This is high stakes. The data science team must find the absolute best algorithm. Because manual experimentation is too slow and risky, they implement a massive, automated comparison strategy. How do they do it? First, they launch an AutoML experiment. This job automatically spins up dozens of parallel runs testing everything from random forests to gradient boosting. Simultaneously, a senior engineer launches a sweep job to fine-tune a custom deep learning script. The key to this entire operation is that both the AutoML jobs and the custom sweep jobs are configured to report their telemetry into the exact same Azure ML experiment workspace. Look at the dual-path architecture for our classification use case. The raw patient data feeds into both the AutoML engine for parallel baseline testing and a sweep job for custom script tuning. Because both pathways utilize MLflow, their distinct metrics and model artifacts stream directly into a centralized experiment workspace, perfectly staging the environment for our final comparison. In part 2 of our use case, the training jobs have finished. We now have over 50 different models sitting in our workspace. The team opens the Azure ML Studio dashboard to compare the results. Why? Because they need undeniable proof of which configuration yields the most accurate medical predictions. Because medical data is often imbalanced, meaning far more healthy patients than sick ones, they ignore raw accuracy. Instead, they use the dashboard to filter and rank all jobs by the AUC-weighted metric. Through this rigorous comparison, they discover that a specific custom sweep trial slightly outperformed the best AutoML baseline. Because the telemetry is perfectly tracked, they simply click on the winning job, register its model artifact, and confidently deploy it to an online endpoint to serve the healthcare application. In this final workflow, we pull data from our centralized experiment workspace. We immediately filter the noise by sorting jobs by our target metric, AUC weighted. The visual comparison dashboard reveals the truth: the custom trial beat the AutoML baseline. We take the top path, select the winning custom job, and seamlessly register and deploy that model endpoint to production. That is the power of comparing model performance across jobs.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.